I will start this presentation with introduction. Okay, for the introduction, force, mass and acceleration are everyday words, but often we use it incorrectly. Force is a physical influence which, when applied to an object, will cause it to accelerate in the direction from which it was applied. Mass is the amount of matter in an object and is expressed in kilogram. Next, acceleration. Acceleration is the rate of change of velocity of an object in the same straight line of an unbalanced force. When force becomes balanced, there is no net force and therefore no movement. Newton's second law links these three terms and concerns the effect that an unbalanced force has on the motion of an object. It states that the rate of change of velocity and an object is directly proportional to force applied and take place in direction of the force. It is summarized in the equation F equal to ma, that is force, mass and acceleration. Thus, an object of constant mass accelerates in proportion to the force applied. Gravity is a variable force of attraction between any two objects. All matter possess gravitational pull towards other matter. Okay, now we will move to the basic theory of this topic. Firstly, Newton's first law of motion predicts the behavior of object for which all existing forces are balanced. The first law, sometimes referred to as the law of inertia, states that if the force acting upon an object are balanced, then the acceleration of the object will be zero. Object at equilibrium, the condition which all forces are balanced, will not accelerate. According to the Newton, an object will only accelerate if there is any net or unbalanced force act on that object. Newton's second law of motion pertains to the behavior of project for which all existing forces are not balanced. The second law states that the acceleration of an object is upon two variables. The first one is net force acting upon an object. The second one is the mass of an object. The acceleration of an object depends directly upon and at the net force acting on the object and inversely proportional upon the mass of the object. As the force acting upon the object is increased, so the acceleration of the object will also increase. As the mass of object is increased, the acceleration will be decreased.
For calculation question 1, an elevator has an upward acceleration of 1 meter per second squared. What will be the force transmitted to the floor of the elevator by a man of weight 500 Newton travelling in the elevator? For question 2, a bullet of mass 0.03 kg moving with speed of 400 meter per second penetrates 12 cm into a fixed block of wood. The average force exerted by the wood on the bullet will be. For calculation question 3, an elevator has a mass of 5,000 kg. When the tension in the supporting cable is 60 kN, the acceleration of the elevator is nearby. Next, for the question 4, two steel balls of 2 kg and 4 kg mass respectively are pressed on the two ends of a spring, all pre-placed on a smooth surface. When released, the smaller balls move with an acceleration of 2 meter per second squared. The simultaneous acceleration of bigger ball will be. Last, question 5. A rocket produced an upward thrust of 15 meganewton and has a weight of 8 meganewton. Question A. When in flight, the force due to a resistance is 500 kilonewton. What is the resultant force on the rocket? For question B. The mass of the rocket is 0.8 times 10 to the power of 5 kg. Calculate the acceleration of the rocket and the direction it's going in.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Azrafi Muhammad Azlan. My matrix number is AA210794. So I will present about discussion. Okay, and I will start for question 1. Given upward acceleration A is 1 m/s square. The weight of man W is 500 N is Newton, and the mass of man M is 500 per 9.81 equal to 50.97 kilogram. The question 1 asks to find the force transmitted to the floor of the elevator by a man of weight 500 Newton traveling in the elevator. So we must use this formula to find the answer. And equal mg plus ma. So n is m equal g plus a in bracket. After this, we just replace the information given in the formula. 50.97 distance in bracket 9.81 plus 1. So the answer is 550.99 Newton. Next, question 2. Given moving with the speed used in 400 m/s, the penetrators S is the 12 cm, and the mass of the bullet is 0.03 kilogram. The question wants us to find the average force exerted by the wood of the bullet will be. So we must use the formula to find the answer. V2 minus U2 equals 2AS and F equal MA. After this, replace the information given in the formula. V2 minus U2 equals 2AS. So negative 400 distance 2 equals 2A distance 0.12. A equals minus 160000 per 0.24. So the A is negative 666.67 ms squared. After we find acceleration, we must find force. F equals ma. So 0.03 distance negative 666.67 in bracket 2000 Newton per 1000. So the answer is 20 kilonewton. Okay, question 3. Given the mass of the elevator is 5000 and the tension in the supporting cable is 60,000 Newton. The question wants us to find the acceleration of the elevator is nearby. So we must use the second law of motion formula to find the answer. T minus mg equals ma. we must replace the information given in the second law of motion formula. So 60,000 minus 5,000 distance 6.81 equals 5,000 distance A. So A is 2.19 ms squared. Next, question 4. Given the mass of two steel balls is M1 equals 2 kg and M2 equals 4 kg, the smaller ball moves with an acceleration A1 is 2 ms square and does not have any force in this experiment. F need equals 0. The question wants us to find the bigger ball acceleration A2. So we must use the momentum formula to find the answer. F need equals M1 distance A1 plus M2 distance A2. So in opposite direction, F need equals M1 distance A1 minus A2 distance A2. So 2 distance 2 equals 4 distance A2. So A2 acceleration of biggest ball is 1 ms square. The last question is question 5. It have two questions, A and B. So A, given the upward thrust of the rocket is 15 mn equal to 15 distance 100 power of 6 Newton, and the weight of the rocket is 8 mn equals to 8 distance 10 power of 6 Newton. When in flight, the force due to air resistance to is 500 kilonewton. So the question want us to find the resultant force on the rocket. We must use the formula to find the answer. F equals upward force minus downward force. So F equals 15 mn minus 500 kn plus 8 mn. So the answer is 6.5 mn upward. So question B. Given new information, the mass of the rocket is 0.8 distance 10 power of 5 kilonewton. Kilogram. The question wants us to find the acceleration of the rocket and the direction it's going in. We must use the formula to find the answer. F equals ma. After this, make to be a single because make A to be single because we want to find the acceleration of the rocket and replace the information given in the formula. So A equals F per m. So 6.5 distance 10 power of 6 Newton per 0.8 distance 10 power of 5 kilogram. So the answer is 81 ms square upward. So thanks, and I will send this presentation to Hamini.
For conclusion, force, mass, and acceleration are assets in the daily things we do every day. For example, we lift things, push doors, run, and so on. From the discussion, we can imply that a force is an influence that can change the motion of an object. A force can cause an object with mass to change its velocity to acceleration. Force can also be described intuitively as a push or pull, or a pull. A force has both magnitude and direction, making it a vector quantity. It is measured in the SI unit of newtons. Besides, mass is the quantity of matter in a physical body. It is also a measure of the body's inertia. The resistance to acceleration when a net force is applied. An object must also determine the strength of its gravitational attraction to other bodies. Next, acceleration is the rate of change of the velocity of an object with respect to time. Acceleration are vector quantities. The orientation of an object's acceleration is given by the orientation of the net force acting on the object. The magnitude of an object acceleration is described by Newton's second law.